stuff. So what I'll do is that I'll peel the onion a little bit and kind of show you like some of the technology foundations we have in our system. But before that, what I wanted to do was do a quick UI demo so that we kind of at least set a stage for where we are. So let me grab a chair,
Thanks,
and I'll show you quickly how it is. I'll come back to this. So this is our main dashboard. We log in, this is what you see. So we also have a plugin which plugs into the vCenter. It looks the same. I'm just using our main dashboard. Just a high-level overview. We know what VMs are pretty well. So it kind of gives you an overview of like what is the system looking like. There are 12 active VMs. There's one data node, one host in this example. Shows you the VM IOPS, aggregated IOPS across all the VMs in the system. It shows you the throughput. And so the latencies are from end-to-end, like Rex mentioned, which is quite different from array latencies. And we also then at the bottom have the how much capacity is used for normal live data, how much capacity is used by the snapshots you have. And then we have this, this is something new we added, like this is not seen generally in other companies, is that it tells you, given the workload you have, it does some analysis and says how much more workload can you put in the system. It kind of gives you a perspective on how do I plan for my, for the next few months if I want to plan something. And so we also have collect millions of data points in our system across all the VMs. We have very fine-grained analysis. We expose some of them here in the UI. And they are stored in our very fast database for a year in the system itself. So you can drill down into any metric you want. And you can drill down over the overall system per host or per VM as you want. So let's say at 2 a.m. somebody said, I have a problem. You can just click on this at this 2 a.m. And you can see all the important metrics you want on the right. And you can just kind of get a feel for how the system was behaving.
This real time?
This is all.
Yeah. I mean, yeah, it's actually real time. It actually moves a little bit as you wait.
This is all API based, so I can get it into other tools as well.
This one is, we don't expose the statistics as API yet. Internally, it's API, but we have not exposed it. Partly because not many people have asked for it, so we have not exposed it.
And how granular is that scale-up potential? Is it like, does it let you do proper what-if capacity planning?
It is like that. So for example, this is one host in this. There's only one host here. It's showing one host. And it kind of knows how much each host is doing, this color shaded a little bit. So roughly tells you how much more hosts with the similar average workload you can add to basically say the system is now can't do anymore. Because at some level, the writes are going to be going to the data nodes. There's a limit to how many writes we can do per second. So that's the ultimate limit to it.
Right, so that gives you the idea of the compute scale up rather than
capacity scale. Yeah. Fair enough.
Right. So that's not what if capacity planning.
Yeah,
really.
actually we thought about it yesterday. The same question came up. We were doing internal demo, and somebody said we should probably add that. So we're actually going to probably add that too. Good question though. So let me walk you through the next tab in our UI. There's the data nodes. In this case, there's only one. It just shows you the high level. What are the drives and what are the if anything looks red, you have to go fix it. And here's a photo of our hardware. If you want to add one more data node, it's pretty straightforward. You add a data node. It has a zero config, zero conf thing, and it'll automatically discover. You can just add it. It'll load balance itself out. And there is a host. We also know what hosts there are. In this case, only one. So we kind of understand the host quite well in terms of what the metrics are, performance, flash. How do we project how the flash is being used, and things like that.
So the Datrium host software, is it? How much memory does it require? How much vCPUs does it require? That sort of thing.
So we use about 8 gigabytes of memory, and we're pretty efficient that way. And also we take up to 20% in the normal mode, up to 20%. And we also have something called insane mode. There's a button to click called insane mode. It instantaneously doubles your performance. We take up to 40% of the CPU.
On the host?
On the host. If you want that extra performance instantaneously, somebody complains, we thought it was a cool feature that if somebody complains the performance, you just click on the button and it doubles the performance.
And the I/O stack, I'm guessing, is pass-through?
Is for write-through, yes. For writes, it goes pass-through. Right. But I think we do I'll show in a minute the technology stuff, how this works.
20% of the host CPU?
Yeah, up to 20% in the normal
case. Okay.
So for every core we take, we get about 10,000 IOPS, roughly. OK, so that was the host. And we also know what VMs are quite well, so you can go look at the VMs. So we have two views for the VMs. We have two databases. One is the data store view, which is the live VMs. And the other one is something called a snap store. So we built a catalog, a search catalog. So if you have millions of objects like VMs and snapshots, and we can do a million snapshots in our system, and other objects we will search, we'll add in the future, we wanted to build a giant, searchable, fast database. So that's kind of what SnapStore is about. I will maybe walk you through that. For example, here, let's look at, let's say I'm doing an app. I'm searching for it. So these are the 3 VMs in the live data store. If I go to the app, there is no such VMs here. Maybe there is something called Win. Yeah, there is one here. So there are snapshots here for that particular VM. So even if you delete the VM from the live data store, the SnapStore still keeps all these items. So the idea is that you'll have a global search where you can search across your different sites, across the cloud and locally, so that you find any objects you want. Same thing for files. You can discover any of the files you have in the system. So networking, we have a page for that. So because we live end-to-end, we are able to detect problems quite easily. So one of the main challenges in distributed system or any system is that if you have a networking component involved, is that the challenge of networking going flaky or it has drop packets. Because we live end-to-end, we can test the network quite frequently and decide that there's a problem and notify the end user or fix it automatically. So far, all the pages I show, I didn't show the protection, but I'll talk about it in one second. But as Rex mentioned, we have nothing to configure in our system. There is no knobs to really play with. If performance is great, generally it is, you have to never come to our pages to look at anything. We built a cool UI, all that stuff, but I'd be hoping you never have to use our UI to do any of this stuff. It's there for just in case of emergency.
So how do you configure like a volume or a VMDK or?
Yeah, so VMware, so in the case of vCenter, you use vCenter. We project a data store, use vCenter for all your operations, which you normally do, which is what you're trained on, which is what your business applications run on. That's what we want you to use. We don't want you to train you again on that particular angle, because everybody's trained on that. There's good APIs, good ecosystem. We don't want you to train on that. We want the underlying system below that to be just looks like a dumb thing.
So you present a single data store like vSAN data stores?
Yeah.
Across the whole cluster?
Across all cluster.
How far, what's the biggest you can get to?
Is 1.7 petabytes.
1.7 petabytes.
Across 128 hosts. We do plan to introduce multiple data stores because some people want it for licensing.
Do you use different VMFS, the VMFS or?
No, NFS. So NFS
right.
doesn't have VMFS involved in it. It just directly talks to a data store.
Support PNFS as well?
Sorry?
Support PNFS as well?
No, we don't support PNFS. Actually, PNFS is not ready in VMware.
Not yet.
Yeah.
Coming.
So one day if they do, we'll probably think about it. But right now, we don't need it.
As far as like frequency of snapshotting or data protection, deduplication, compression, those sorts of things are all automatically turned on?
No. So the one thing we could not decide is, we could not figure out is that how to set backup policies, how to do the frequency of snapshot. We thought about it quite a bit, actually. Maybe one day we'll figure it out, like maybe automatically snapshot every 5 minutes and keep them. But at this stage, we thought that was too intrusive in people's, it requires capacity planning, all that stuff. So that's why we have the page here, protection page, where you have to configure, unfortunately, some policies and how you want to manage your backups and replication, because we could not figure out how to automate that yet today. So until we figure that out, I think you have to configure the policies.
Do you support most of the VAAI primitives?
VAI primitives, yes.
All of them?
Yes.
Including storage unmap as well?
The storage unmap is not available for NFS.
Of course.
Yeah.
Fair question.
So the way it works is that
I forgot that.
if you want to so basically the way it works is that we have something called policy group, protection groups. They're kind of policy groups. If you have too many VMs, hundreds of VMs, you can't click on every VM to set policies anymore. It's just too much work for administrators. So what we have done is that, so let's make a policy group. So let's call it Silver, TFD. So we have two options here. You can either select your policies for VMs as pattern matching, or you can select it as individual VMs if you want to. Like, for example, you can select individual VMs if you want to, or you can just say, look, I know my applications have a pattern. Most people, actually, a lot of people do have a naming pattern for their VMs. You can just say that, and this is the preview you get of the applications. So the idea is that whenever we take a snapshot of this particular policy, we will try to investigate all the names which match this pattern, and then put that it belong, which then we say this belongs to this policy.
So no like vSphere tags or folder support right now?
Not yet. We're working on it, but we do want to do that actually. Both of them actually have similar problems. Is that when you have either pattern matching or tags, when you try to evaluate the pattern or tags, you may end up with an unbounded number of VMs, which is kind of be solved. Is that so? This policy group, for example, if you say star, you can't just say star. I don't care. Just put everything in it. Simple. Like you say star, I'll have backups every day, once a day for everything, and then you can set different policies for different groups. Each of these policy groups can have 6,000 VMs in it. And the other thing we have done is that when you take a snapshot, we snapshot all of them together. So it's not like one after the other. We believe that if you take one after the other, like backup does, when you try to recover, we have a disaster, they're all in different points in time. And then how do you make sense of your business applications when they're all in different points in time? So we snap them all together. So when you recover, they all come back together. And it's done not from VMware snapshots, it's from Datrium snapshots. So it's a glitch-free. You'll see no effect on your performance when we do all this.
What about the file consistency, though?
VSS. Yeah, so we have VSS, so I'll show you in this case. So if you click on one of these, for example, for VSS, people care about like a couple of VSS, not everything. They care about like this MySQL database. So in that case, you can do like this, and you can click on Use VSS. So we have an agent which can run in the, so we can detect that it's not there and complain when you say click on this triangle thing. It says it's not there, you got to go install it. We'll accept this policy you set, but we'll complain to you regularly that we cannot take VSS snapshot. We'll still take a normal snapshot, a crash consistent snapshot if the VSS is not there. But we'll complain to you that there is a problem, so you can go fix it.
Are you able to run a script? Like before in a VM, let's say in a specific VM, to say prior to it, can you just run this and stun your database, do whatever you want to do from the app level?
Not yet. We just do VSS for now.
Can you push that agent out, or do I have to manually install it?
I think right now it's manually installable. Mike, manually installable? Yeah.
Linux, obviously, you don't have VSS.
Sorry?
Linux, you don't have VSS.
Because we don't have VSS, yeah. So we do want to push I've add the button here one day, like where I think we should say just push the VSS. We'll probably push it. OK, so.
And then it'll snap at the data store level.
No, it'll snap at the VM level.
VM level, right?
So we are very fine-grained. We can actually snap at individual VM decays.
Yeah.
So we are very fine-grained that way. We understand each object in VMware. So in this case, if we did a star, it'll snap everything, all the VMs in that data store, all the live data store. But so you can make all these policies. So also we found that it's not just VMs sometimes people care about. People care about like ISOs. So you can set a policy like this. Okay, say, look, I have a bunch of VMs and there's a policy for it. So okay, here's my thing. So you'll pick up all these ISOs if you want to be part of that. So then in the scheduler, so basically you can do daily, hourly, half-hourly snapshots, and you can then pick multiple schedules, and you can replicate these snapshots to multiple destinations. I think you asked a question about one-to-many. You can do one-to-many, many-to-one, both ways. You can have different detention policies and stuff like that. So maybe I'll stop just quickly wrap up the demo and say that ultimately you do backups for a reason. The reason is not to do backup. The reason is to recover. It's all about recovery. So we have provided a lot of features to do recovery, restore, and how we want to operate at very, very fine-grained level. So ultimately, backup is all about restore. So I'll stop at that. What is going to happen is that once I'm done giving a little bit of the technology foundations discussion, Tushar and John will walk through how the cloud and some of the other things work in this particular part of it.